And to the average layman, these simply mean clouds, in varying formations of beauty and majesty. To the experienced pilot, however, these towering cumulus buildups mean much more. Flight through any of these clouds could mean severe turbulence and heavy icing, exposing his important cargo to possible disaster. This, too, is a beautiful sight when you're on top. You know these are true rain clouds, and below, visibility and ceiling are probably very poor. Your future safety depends a great deal on your ability to understand the weather, particularly the hazards it can produce. Intelligent use of the surface weather map will enable you to recognize and visualize many of these hazards. Almost all weather is caused by the movement of massive bodies of air, commonly referred to as air masses. An air mass is a large body of air having relatively the same horizontal moisture content and temperature distribution. It can be cold or warm, and it can be moist or dry, depending on its source region. The two major source regions of air masses that affect flying over our continent are the polar and the tropical areas. Often the question arises as to why air masses move. Let's consider the Earth as a smooth sphere, with heating occurring at the equator and cooling occurring at the poles. The warm air at the equator and the cold air at the poles will tend to move so that equilibrium will be reached between them. The cold air moves southward and the warm air moves northward, resulting in a regular pattern of waves in the middle latitudes. But the Earth's surface is not a smooth sphere. The water areas, land areas, and mountain areas cause this wave pattern to become irregular. Lateral mixing continues as cold air moves southward and warm air moves northward, producing the movement of air masses within the atmosphere. Some polar air masses originate in the northern waters of the Pacific and the Atlantic. In both cases, they are cold and moist because of their origin over water at these high latitudes. On the other hand, polar air moving down from Canada would be cold and dry. Dry because of its origin over land. Tropical air masses originate in the Gulf of Mexico and the Atlantic Ocean at the same latitude and flow into the United States. Under normal conditions, the South Pacific source region is of little importance as far as air mass weather in the United States is concerned, since the circulation around the Pacific High draws this air away from the continent. The greatest influence on air mass weather is the terrain over which the air mass is passing. Consider a polar air mass moving southward during the day. Such air moving over the warmer surface becomes unstable. Unstable because vertical currents will develop as a result of the cold air being heated from below. To be sure you understand this theory, let's make an analogy. Place a container of cold water over a flame and allow it to heat. As the heating process continues, you can actually see the vertical currents develop and become very lively. This is much the same thing that happens in an air mass when it is heated from below. The vertical currents that do develop cause the air to be rough and turbulent. This poses a problem to low-performance aircraft. But for high-performance aircraft at cruising altitude, little or no turbulence is apparent. Of course, turbulence and all types of rough weather must be considered if you plan a penetration into a situation such as this. Now, let's take a look at a moist air mass as it moves over the warmer land. Again, vertical currents develop as the air is heated from below, but because of the moisture contained in the air mass, the vertical currents cause cumulus clouds to develop as the air rises and cools adiabatically. In the initial stages, The updrafts and downdrafts associated with these vertical currents cause the cumulus clouds to form in scattered or broken layers with open areas in between. The base of these clouds will generally be several thousand feet above the surface. Flying on top will be smooth, but flying through, around, or below these clouds can be rough and turbulent. Under certain atmospheric conditions, particularly in the south, the cumulus clouds may continue to build to 50 or 60,000 feet, cover a large area, and produce showers and thunderstorms. When you fly into heavy cumulus buildups, you can expect severe turbulence, damaging hail, and the possibility of heavy icing. Any or all of these conditions are extremely hazardous. In the areas of heavy cumulus activity, visibility is restricted by the clouds and heavy precipitation. However, in areas where the cumulus buildup is not so heavy, the vertical currents cause the distribution of impurities, such as haze, dust, and smoke, throughout a very thick layer. Thus, visibility is generally good in this situation. The vertical currents also prevent fog from forming. The types of precipitation which occur in an unstable air mass are rain showers or snow showers, which are frequently heavy. The poor visibility and low ceilings produced by these showers are generally temporary. Often, if you have enough fuel and plan carefully, you may be able to make a VFR penetration after the showers have passed the field. Now let's see what happens to a similar air mass that has originated in the Gulf during the winter season. The land area being relatively cooler than the air mass will produce cooling from below. No vertical currents will develop, and the air mass will be stable. Low stratus clouds and fog will generally form. Remember the container when the cold water was heated? The vertical currents that were set up became very lively as the heating process continued. Now, we'll transfer the container onto a piece of ice. This cooling immediately slows down the vertical development in the water, and eventually all activity stops. The water becomes calm. This again parallels what happens in an air mass. In this case, the cooling from below has caused the air to become stable with little or no vertical currents to consider. Flight through such air will be almost free of turbulence. The clouds that form will be in decks and sheets. They have smooth, flat tops and bases and may cover great areas. The bases of these clouds will generally be low. Impurities such as smoke, dust, and haze will be concentrated in the lower layers, and you can expect fog in this stable condition. As a result, you can expect poor visibility, particularly at low altitudes. The types of precipitation usually associated with stable air are light rain, snow, or drizzle that may be either continuous or intermittent. You have seen how heating and cooling from below can affect the weather in an air mass. However, there are other things to consider. For example, let's observe this air mass from the Pacific as it moves over the mountains along the west coast. The rapid lifting of the air by the mountains causes the air to become unstable. Vertical currents develop, causing turbulence and rough flying conditions. Again, cumulus clouds may spring up and build into thunderstorms. In the rain showers beneath these clouds, the ceilings will be low and the visibility poor. When the air mass descends beyond the mountains to the Great Plains area, the cumulus clouds tend to dissipate because the relative humidity decreases and the air becomes stable. This decrease in relative humidity is caused by adiabatic heating as the air descends. We have shown you the general characteristics and the causes of both the stable and the unstable air mass. Remember that the unstable air mass produces cumulus clouds with generally good ceilings. Visibility is good except in areas of heavy cumulus activity and precipitation. Turbulent or rough flying conditions will be encountered, particularly for low-performance aircraft. The stable air mass may produce layers of stratus clouds, As a rule, you can expect poor visibility. Light rain, snow, or drizzle may occur, but smooth flying conditions are generally associated with a stable air mass. When you get a briefing from the weatherman, he will speak to you in terms of the situation shown on the surface weather map. To follow the briefing, you must understand and be able to apply principles of air mass weather, principles that are valid anywhere in the world.